I will talk about an overview of the different AI techniques that they exist in the University of Manchester, and some insights about the things that we can do at the university. So for the first question, and perhaps this is known to several people, but I think it's very important to say that what AI is, and obviously AI refers to systems that display some kind of intelligence, and they're able to analyze their environment. And as an enabling technology, it allows to analyze data, to plan, to predict, and to reason over different types of data. And the data, there could be different types. There could be textual, images, videos, all sorts of things. And because we have different types of data, we have different technologies and different applications. So I'll discuss a bit about the technologies, but which are basically, some of them are computer science and AI, and how these have been applied to different areas. So important for us to understand is that if we want to find patterns, and sometimes if you have lots of dimensionality in data, it's very difficult to do it manually, but AI helps us to find those patterns and find lots of different connections. And important here is that the AI makes for having in a cultural environment is not a static way of viewing at things, but makes it a bit more dynamic. We can explore culture based on our interests or other people's, for instance, and engage with other people. And this is all feasible right now because there have been massive digitization efforts in the UK and abroad, which makes actually our data usable and very accessible to apply AI techniques. Knowledge that we have in the University of Manchester, and some of those we're doing, and of course some kind of insights of where we can go next. So first, an important part of knowledge is computer vision, which includes recognition and this technology, they tend to shift, basically switch from a kind of classical AI to more based on machine learning. And we'll hear a lot about machine learning and also deep learning increasingly. I won't give you learning and machine learning because I don't have the time. Keywords to remember, and things are happening because to knowledge. So this is also very important because of the deep learning and the machine learning, image recognition is not so much an expensive effort, but is more amenable and more able to use for several environments. Generation, which is actually how we can generate images which look very close to the real ones. We can have a variety of users again. So, for instance, augment search facilities by generating image or finding related images. We can also edit them. We can create content for navigation, for instance. So it's also an important part of generation has impact, like for instance, fakes, and they are able to identify detection. So imagery that is not basically for good purposes, but also in types of information, textual information, we can have misinformation. Other things that related with the main technologies is embodied vision. They can be basically AI systems that can be interactive, or they can be embodied a part basically of the physical environment. So you can have robots surveying an environment in a cultural space. And there is also areas like digital humanities, which I'll describe a bit more later, and also cultural analytics, which combine images and text and kind of immersive environments. So I mentioned a bit this because we do a lot of work in text, and I think it's important to understand a bit more how we are using unstructured data to develop different applications. And for this, in the environment, for instance, of culture or of history, we can retrieve information, we can support navigation, we can add what we call semantics on raw unstructured text to be able to discover, for instance, trends, to do search, to do discovery, to make connections which are not necessarily evident. And in digital humanities, which actually there's also a part at the Institute of Data Science and AI, we have a branch of digital humanities. Basically, the fundamental part of the question that we are asking in NLP in this case is if we can actually develop machines that they can emulate the human brain. And we're doing this a lot in natural language processing text mining because we use, we're emulating, we say benchmarks, we're trying to compare the human and how we systems. And I'll give you a couple of examples here. And this is the work, for instance, we are doing in the computer science. So you have like a reading comprehension batch, a more answer question similar to human performance. And there are also other benchmarks like super glue as well, which is developed by Microsoft, the Berta model. And you give the same tasks as humans, and then the humans will compare. So the way we measure that is we call about F-scores, but to give you an understanding how well machines do, the human performance is 91% in certain tasks for question answering, and the machine comprehension is 95%. And we combine vision and language reasoning, we still have a very good, the human is 80%, the machine is 76%. So what are the technologies that we have? I just put some of those. We're working at the university, but also to see the future. We work a lot on machine learning, on deep learning, on probabilistic modeling. We're working on deep brains-inspired AI, data and knowledge integration AI, and then we have components, modules. So these are the fundamentals we're doing. And those little boxes that you see above are components that we can put together to do, for instance, different applications. And I mentioned about NLP, but it's computer vision, we do planning, we do prediction, we do voice recognition, HCI systems, augmented reality, virtual reality. So how we can actually explore that? We are applying our tools, our techniques on massively digital, and this could be on artwork of historical data. And what actually we are trying to do is to be able to classify different types of information using these techniques. So I have examples here. It's not from our side, but from other people, other universities and other teams that you can find related, for instance, images from 3D prints and compare them together and uncover relations between different images and allow the users to interact with these images. Or we can create virtual assistants, and based on our feedback, that can guide us through a museum collection or through archives. So the art actually is quite, interestingly, is quite complex, because if we see an image or a painting, we can find lots of elements that we cannot necessarily immediately, that can be perceived by different users in different way. So for instance, we can think what are the colors, what's the palette, what is the art, and what else, other informations we can add into a painting. And this is why we have this kind of collections where we can connect between descriptions or people's interactions and the images. Another part actually, which is very important, the cultural heritage we actually work, is to look at standards, because any kind of digital documentation follows certain data formats, standards, and there is a lot of work on that, not necessarily from our university, but wherever, if we work in that area, we need to be aware of these basically standards and data formats. And other things we're doing is on crowdsourcing and how we annotate data. And this, again, it depends on the point of view of how people look at the painting and how they label it, or if they look at other historical archives and annotate, mark them up for machine learning systems, basically, to classify them. An important part here, which some of us start working is on AI, is bias. And although we work on bias in AI, but it's also very important how the systems and the models we're using are basically geared towards a specific type of culture. And it has been, already proven that we have a very specific view of looking at cultural intelligence. So the world perhaps is, some people say, more male, more Western-centric point of view, rather than more, open to other cultures. So this is something increasingly people are very concerned and trying to remedy the fact there is bias in AI, and includes also cultural heritage. And to do that is actually, crowdsourcing is very important, because we can then collect narratives from other people to be able to reduce the bias that we currently have. So this is from other people, but I thought it's very important to mention it, that we talk about some of what we can, for instance, create art through 3D, not from our project, but next Rembrandt, and how we can basically even create paintings in 3D. So this painting is completely artificially exactly to that Rembrandt would have done. So this is actually how we're generating features from images, how we discover the proportion of AI and deep learning and vision. How, for instance, so we can get the environment from drone, then with satellites, and then how we can recreate artifacts. I'm a linguist, I'm very biased. Also, because we work on learning, there are many things that we can do in linguistics. For instance, an example from colleagues at MIT who actually languages using, which I think is a phenomenal type of work. Neural methods to decipher resource languages. So they're going from Ugaristic to Linear B, and Linear B is actually notorious for being extremely difficult to decipher. And the important here is that for the humanities and in culture, or with the artifacts that they're very scarcely resourced, we can actually learn, we can decipher information using machine learning and deep learning. So you cannot even use machine translation, because we have a few components actually of lost languages. So those are, and we'll talk about historical linguistics, because typically languages evolve in a very specific, predictable ways, and we want to be able to capture that. So then I'll finish my talk with some work we've done at my center, which we used historical data from since 1840. And this, although it was historical for medicine, there were certain things that we had to take into account, like, for instance, how we clean up the data, how we recognize handwritten text, and how we correct OCR material. Most of the digitized material is basically OCR, and this creates errors. So, for instance, you have to we develop methods that automatically correct, find correct changes. But if, for instance, an OCR method has incorrect or errors, we automatically correct them. So just to give you, and I'll finish with that, what you could do if you use, old archives. So you can use systems which are not based on keywords. So if we have terms or entities, you can start finding related things, and also find how terms and concepts change over time, which is very important, specifically in culture. So there are lots of changes in our culture, and perhaps terms, concepts are used in different ways. So we want to be able to capture that, to allow now people to search those archives without necessarily knowing the terms. Those are basically, we can see here how different terms vary over time, and understand why in 1840 a certain concept was very, for instance, not so useful, or suddenly we see in 2000 pneumonia, for instance, is peaking. And then a bit more. So, and also we can look more at the content of the different content of articles to see how different semantic types are related. So what are the documents are talking about? What are the interactions between the concepts? And that's all from me. Thank you.